Okay, in part 2 of this tutorial, we're going to cover wave superposition. So we'll be looking at what happens when waves interact with other waves. Since we know waves are energy, they can actually overlap because they're not matter. So and when they do, that's called superposition. So a good way to think of this is waves in a bathtub, right? If you send one wave in a bathtub, it just goes and then dissipates out. But if you keep producing more and more waves, as they bounce back off the edge of the bathtub, they're going to start to interact with each other, and sometimes they'll actually build up, and you can end up with a huge wave that splashes out of the bathtub. So that's a real simple example of superposition. So let's look at this a little more quantitatively. We're going to start, we'll send two waves towards each other. They're going to come from opposite directions. And for simplicity's sake, again, I have it set so that it's a half wave. So we can see they're moving towards each other. And so the question becomes, what's going to happen when they overlap? I'm going to turn on ghosting so it'll show traces of the two waves even when they are interacting, and let's see what happens. So what happened there when they went past each other? Let's watch that again. And this time we'll actually go through frame by frame, and what we can actually see is as they overlap, the wave grows. And in fact, when they are perfectly overlapped, it looks like this wave is approximately twice as big as those two waves. So that is called constructive interference. Constructive interference is when waves of the same displacement, right? Both of those waves had positive displacement or positive amplitude. When they overlap, that's called constructive interference, and they actually make a larger wave. So the question then becomes, what would happen if we do it so that they are opposite displacement? So now I have two waves moving towards each other to overlap. One has positive displacement or amplitude and the other has negative. So when they overlap, let's see what happens. Right, the wave didn't get bigger that time. So we'll do this again, and we will pause it and move through. And what we actually notice is the wave, this wave has the purple wave or blue wave has a positive amplitude, and the other is green, and it looks like they're actually canceling each other out. And sure enough, when they are perfectly overlapped, they completely cancel each other out, and there's no wave there whatsoever. So this is called destructive interference. Destructive interference is when waves have opposite displacements and they add together to result in smaller waves. So we can actually look at that quantitatively. If I adjust the amplitude of this wave, it's going to be 16. So now what I really have over here is I have two waves that are about to interact. One is minus 16 and the other is a positive 12. So we can quantify what actually happens, right? So now when they interact, they don't go away entirely. I have a minus 16 plus a negative 12, so that resultant wave actually has a magnitude of minus 4. So I can quantify what's happening, what kind of destructive. This is still destructive interference because they're adding together to make a smaller wave, but I can see that quantitatively it is actually minus 4 magnitude. So then we can assume the same thing is going to happen with constructive interference. So I'll run this through again. I have 16 and 12. Now you'll notice they both have positive. So I should have plus 16 and plus 12. So let's predict, what do we think the magnitude of the overall wave will be? It should be bigger. Sure enough, it grows. When they're completely overlapped, it's bigger than both of them. So we would know that it would be 28 centimeters in magnitude. So those are the two types of interference of wave superposition. Constructive, when they add together to make a larger wave, and destructive, when they add together to make a smaller wave.